dimensions. So we're learning about how changing dimensions affects perimeter, area, and volume. Okay? So our first question here, how does doubling the radius, so 3 centimeters to 6 centimeters is double, how does doubling the radius affect the circumference of the circle? Okay, so a good plan for this question whenever we're comparing is to find the circumference of each one, and then how do you compare them? What operation? Add, subtract, multiply, or divide to compare them. All right, well, yep. Nope. Nope. Divide. Very good. Process of elimination. Okay, so who can tell me from your formula sheet the formula for the circumference of a circle? Circumference, which is perimeter. Okay? Yeah. 2 times pi times radius. Okay, so let's do it for this circle. So, you can see? Move it up a bit. Okay, so 2 times pi and our radius is 3. And then you've got to be able to put that in your calculator, right? So you tell me what it should be, and make sure everybody can get that on your calculator. If you can't, ask your tutor how. 2 times pi times 3.
I couldn't tell you what pi is. What's that?
What did people get for 2 times pi times 3? 18.8, awesome. 18.8 centimeters. And then let's do this one. So we're also finding circumference, so we also use the same formula. Yeah, on this calculator, because there's also x on this calculator.
So this is thick. I've never seen this before.
Yeah, the graphing.
This is the normal one I use.
So the radius for this one is 6, which is double. Remember, so this is we had to times by 2 to get from to change the radiuses. So now you want to do 2 times pi times 6. Which is approximately 37.7. So then we decided dividing would be comparing them. So 37.7 divided by 18.8 is about 2, right? We used every single decimal place. For pi, we get exactly 2, but our calculators don't hold that many digits. So if you double the radius, what happens to the circumference? By a factor of 2, which means it doubles also, right? So if you double the radius, the circumference is doubled. What do you think would happen if I tripled the radius? What would happen to the circumference? It would triple, yeah. What if I multiplied the radius by 5? The circumference would be 5 times as big. 5 times as big, okay? So whatever you did to the radius, it's going to match what happens to the circumference. Does that make sense? Whatever you did to the radius, it's going to match what you did to the circumference, okay? All right, so now we're going to look at the area for each one of our circles, okay? So for the little circle, first we need to look on our formula sheet and get the area formula. Yep, pi r squared. And and our radius was 3 for the little circle. So then you got to make sure that you can get pi times radius squared on your calculator. Josh, make sure you're typing on your calculator, because you can't, if you're on EQA and you don't know how to type it in, then you're up a river.
Wait, you said the last, or the second last?
Lesson? Yeah.
The last would be more.
Yep. And then Monday we're doing EQA, Monday and Tuesday we're doing EQA overview, then a culminating assignment, and then EQA on Wednesday. And then Thursday, finish culminating assignment. Okay, what did anyone get for this? Anyone calculated yet? Grade 9? Yep. 28.3, that's what I got. So 28.3, and what are the units for area? Centimeters squared for area. Okay? All right, so now let's find the area for the big circle. So the big circle, the radius was doubled, so it was 6. And if you type that into your calculator, what do you get? What did you get? 113.1. That's what I got. Centimeters squared. And then we compare them by dividing. So we take our bigger one and divide by our smaller one. And that'll give us approximately how many times the little one goes into the big one. So 3.996, so approximately 4. So when we doubled the radius, the circumference doubled, but when we double the radius, the area quadruples, right? The area is 4 times as big. Can anyone explain why, the difference? Why does doubling the radius double the circumference, but doubling the radius makes the area 4 times as big? Why is that? Because, yes, that's exactly it. So in the formula, here radius is squared, okay? So I'm doubling the radius, so I'm timesing it by 2, right, the radius? But the radius is being squared, so I'm really timesing by 2 squared, which is timesing by 4. Okay? Whereas in our circumference formula, r is just to the power of 1. So if I'm timesing the radius by 2, I'm just timesing the radius by 2. Yeah? Yes. Okay, so very good, Jacob. All right, so for me, if you can catch on to that, that's your level 4. If you can just work them out and divide and figure out the answer, that's your level 3. Okay? And both of them are all you need to know for this course. Okay? Rectangle 2 is made by cutting both the length and width of the rectangle of rectangle 1 in half. How many times smaller is the perimeter? So if I cut the length in half and the width in half, then I'm just looking at this rectangle here. Do you guys agree?
Right.
That would be the littler one? Is that right, Charlie? Okay, read the question. Rectangle 2 is made by cutting both the length and width of rectangle 1 in half. So is this green one rectangle 2? Does that make sense? Yeah? Yeah, so what would this one be then? I was just getting to that, Kylie. So if I divide 6.5 by 2, what am I going to get? 6.5 divided by 2, 3.25. 8.5 divided by 2, 4.25. So how do I get this, the perimeter of rectangle 2? That's area. Perimeter, you add up all 4 sides. Agreed? Is that how you get perimeter? Just common sense, even not using a formula, you just add up all 4 sides. Everybody good there? So my 4 sides are going to be 3.25, 4.25, and then another 3.25, and then another 4.25. Add them up, and I've got the perimeter of the smaller one, right? So it's going to be 20, 10, 15. So the perimeter is 15 centimeters. Rectangle 1, we add up all 4 sides, and they were given to us. We add up all 4 sides. So we've got 6.5, 8.5, 6.5, 8.5, add them all up. 30.0 perimeter. So if you cut both the length and width in half, how many times smaller is the perimeter? I take this perimeter and divide by this one. 30 divided by 15 is 2. So the little one is twice as small. That 2 there means the smaller one is twice as small. Smaller one's perimeter, let's say, is twice as small. Or you could say half as great. Okay, so again, all you have to do to understand this question is to know how to find perimeter of a rectangle by adding up all the sides. Okay? That's all you have to do there. And then part B, how many times smaller is the area? So for the area for rectangle 2, the area is, like Kylie already told us this one, length times width. And for the littler rectangle, the length is 3.25 and the width is 4.25. So we just multiply them. And we get 13.8 approximately, and that is, it's in centimeters squared. Area has square units, remember? And then we need the area of the bigger rectangle, rectangle 2. So again, we're just going to do length times width. So length is 8.5, width is 6.5. And then how do I figure out how many times smaller the area is? What did we do in all the other ones? what do we do here? 30 divided by 15. So big one divided by littler one. So 55.25 divided by 13.8. Approximately 4, which it would be exactly 4 if we use all our decimal places. Okay. So that means the smaller one is 4 times smaller. Which is what you got for the thinking question right at the beginning, right? You got the surface area was 4 times smaller by cutting all the dimensions in half instead of twice as small, which is what the prism is. Okay? This is rectangular. All right. Prism D is made by doubling the height of square-based prism C. So they show them both to you. So all we did was double the height. It wants to know how many times larger is the volume of prism D. So I'm going to pause it. Prism C. Length times width times height. Prism D. Okay, a lot of people could just look at it and say it's double. You can always divide. So prism D has twice the volume of prism C. How come it was only twice and not 4 times or 8 times? How come it was only twice? Yep. And we only changed one of the dimensions. What do you think would have happened if we doubled all of the dimensions? These would all be 20, right? 20 times 20 times 20 is 8,000. So it would be 8 times as big. 2 for each of the ones we changed. Twice as big for each of the dimensions you changed. Okay? All right, so number 4, a cube with a side length of 4 centimeters is enlarged so its side length is 8 centimeters. How many times larger is the volume of the new cube? So if you need to draw a picture, so we've got a smaller cube. Not very good at this, but try here. So 4 by 4 by 4. And then we have a bigger one. Which is 8 by 8 by 8. And we want to know how many times bigger. Yes. How many times bigger the bigger one is by volume. When you look on your formula sheet, what does it say for volume of a cube? What does it say? No? It says B cubed, doesn't it? Oh, area of the base times height. Yeah, or side cube. Or you could have used length times width times height, right? And then just all be the same number. Everyone good with that? Okay, so base cubed then means 4 cubed. 4 cubed, right back to unit 1. What's 4 cubed? Not 12. 64, good. 64 cubic centimeters. And now we want to do the same thing over here. But this time we're cubing 8. $512. Once I know those volumes, how do I see how many times larger the volume of the new cube is? Our last step, let's do. Yep, divide. Yes, 512 divided by 64 is what, students? Awesome. So the volume of the new cube is 8 times as large. And that's because we changed each dimension. We multiplied each dimension by 2. So this one was multiplied by 2. This one was multiplied by 2. And this one is multiplied by 2. So multiplied by 2 3 times. 2 times 2 times 2 is 8. So it's 8 times as large. Okay. Yep. Yep.
Cube B is the length is going up, so it's 18 dimensions or 4. Does that not make it a rectangular building?
So for a cube, when it says side length, it means all the sides. Because all the sides have the same length, but that would be one. If you were a rectangular prison, you'd be right. But a cube has that special property. So it's okay. So our next one, a pet store sells a small aquarium is shown below. They also sell a larger aquarium whose dimensions are triple the smaller one. How many times greater is the volume of the larger aquarium than the smaller one? Yeah. It was the question for the tutors.
Yeah.
What do you have to do to each dimension so that you have half the amount of hardware?
All.
What? Any of them. What do you have to do in order to get exactly half the amount of hardware?
That's your volume for your small module. So did you really want to see all the
Okay, so for the bigger aquarium, it says the dimensions are triple. Triple means times what? Triple? No, William? Triple means times what? Right. Doubles times 2, triples times 3. So I want to multiply that by 3. 30 times 3 is 90. 18 times 3? 54. And 26 times 3? 78. So then I figure out this volume is going to be a lot bigger. 379,080 cubic centimeters. And now I need to know how many times greater is the volume of the larger aquarium. So there's my divide step. So I need to divide this number by this number. And that'll give me how many times bigger it is.
27.
27? Nice, good job. Anyone can tell me why it's 27? Right, I multiplied each dimension by 3, so basically I multiplied this by 3, this by 3, and this by 3, and 3 times 3 times 3 is 27. Okay? All right, our last question of our second last lesson. The height and radius of the cylinder are both doubled. How many times greater is the volume of the larger cylinder?
So it would be equals pi
Okay, one thing that's interesting that the textbooks always do here, and sometimes EQAO does here, is if they leave it in terms of pi, you don't have to be able to do it, so I'm going to do it both ways. So the leaving it in terms of pi would be to multiply these guys together. So 3 squared is 9 times 14. So this gives me 126, but I'm still multiplying by pi. So they leave the volume as 126 pi rather than as a decimal. Okay? But if you were to multiply pi times 3 squared times 14, you'd get the equivalent of this as a decimal. So do that on your calculator, pi times 3 squared times 14, and you'll get approximately 395.8. And I'll show you the reason they would do that instead when they're comparing. Okay, I'll show you the reason they would do that instead when they're comparing. But these are equivalent. 126 pi is the same as 395.8. You can try multiplying 126 times pi and you'll get 395.8. Okay? All right, so let's do the larger one now. So our radius is doubled. Both the radius and the height are doubled. So our radius was 3, it's going to be 6 now, doubled. And our height was 14, it's going to be 28 now. Does that make sense? And then if I just multiply these two together and get my volume in terms of pi, I get 1008 pi, or approximately 3,166.7. Now, watch what happens if I divide 1008 pi by 126 pi. What happens to the pi's? Nothing? What's pi divided by pi? Any number divided by itself? 1. So these guys cancel out, and all I have to do to calculate it is 1008 divided by 126 rather than using decimals, and you get exactly 8. But if you divide this by this, you'll get about 8. Okay, so it doesn't matter which one you do, you'll still get the right answer. Okay, but that's the reason they do leave it in terms of pi, because the pi just cancel out and you do pi. Okay, again, this leaving in terms of pi would be a level 4 thing to do. Okay. Just being able to get them and divide level 3. Okay. All right, so then in our sentence, how many times greater is the volume? Therefore, the volume is 8 times greater. Remember to make sure you can get those numbers in your calculator and ask your tutor or myself for help. You'll need to be able to do those. So you've got some time to start the practice. Do this, maybe the first 2 questions, and then I'll give you some time tomorrow to do more of them, okay?